Today we're going to be talking about zero and negative exponents. So yesterday when we were dividing exponents and subtracting, I made sure to give us problems where the exponent always stayed positive. But that is not always going to be the case. All right, so let's go through our negative exponent rules. So first thing, anything to the zero power is always 1. So if I have z to the 0 power, that is just 1. All right. In general, when you have a negative exponent, in order to make it positive, you are going to turn the problem into a fraction. Okay. So for instance, if I have a to the negative 5th power, I do not want that negative 5 exponent. So I'm going to write this as 1 over a to the positive 5. All right. And then this last one is kind of cool. If you have a fraction taken to a negative exponent, if you flip the fraction or use the reciprocal, you can then change the exponent to a positive exponent. So for instance, if I have x over y to the negative 4th power, that's going to be the same thing as y over x to the positive 4 power. All right, and then we use that exponent rule from yesterday. Y to the 4th, x to the 4th. All right, now let's look at some problems that will deal with negative exponents. So the first one, we have x to the negative 6 times x to the negative 3rd. All right, so we use our exponent rule from yesterday that tells us we're going to add those exponents together. So x to the negative 3 plus negative 6. Well, that gives me x to the negative 9. Remember, I'm not allowed to have negative exponents. So to make that exponent positive, I'm going to do 1 over x to the 9. All right, number 2, same thing. I need to use my exponent rule from yesterday first that says everything inside of these parentheses is going to get that exponent. So this is 2 to the negative 3rd, x to the negative 3rd. Well, in order to get rid of that negative exponent, remember I change it into a fraction. 1 over 2 to the positive 3rd, x to the positive 3rd. And then last step, 2 to the 3rd power is 8, x to the 3rd. All right, number 3. Again, using multiple rules here. So we are multiplying these two monomials together. So 2 times 5 is 10. And then this is going to be x to the negative 2 plus negative 9. And then y to the 3rd plus negative 2. Add those exponents together. All right, so here we have 10x to the negative 11th, y to the 1st. Now, we have not had one like this yet. Notice that the only piece of this equation that has a negative exponent is the x, okay? Only things that have a negative exponent get turned into a fraction. So what that means is the 10 and the y can stay on the top of the fraction. There's no problem with those. However, the x to the 11th has to go to the bottom in order to make that a positive exponent. Okay, and we're going to see this again in number 4. So in number 4, we have 3x to the negative 6. In this problem, the only part that's negative is the x to the negative 6. The exponent on this 3 is a positive 1. So therefore, the 3 can stay in the numerator, but in order to get a positive exponent on that 6, I move it to the denominator. Okay? Problems like number 5, you should always be very, very excited to see, because remember our rule, anything to the 0 power is always 1. So if I have 4x squared raised to the 0 power, 1. All right, and now we've got this quotient one here. So remember, when you are dividing exponents, you are subtracting. So this is where we have to be very, very cautious with our negative signs here. All right, so first thing, we have the coefficient. 12 divided by 4 is 3. All right, so then I'm taking x to the negative third, and I am subtracting negative 5. I'm taking y to the negative 6, and I am subtracting 4. And then finally, I am taking z to the second and subtracting 9. All right, now why I said you have to be super, super careful is, for instance, this first one. These two negatives are going to make a positive. So I have 3x, and then I have negative 3 plus 5, which is positive 2. And then y to the negative 6 minus 4 is negative 10. And then z, negative 2 minus 9 is negative 7. All right, and like we expressed before, we are not allowed to leave things as negative exponents. So I like to just highlight the pieces with the negative exponents, because those are the only thing that are going to be moved to the denominator. So for instance, on this one, the 3x squared is positive, so it can stay in the numerator. But the y to the negative 10th is going to move to the bottom to be positive. And the z to the negative 7th is also going to move to the bottom, so we can change it to a positive exponent. All right, so we are not allowed to leave anything as a negative exponent.